2014 B1. Right, part A. What is centre of gravity? Yeah?
Point above the fixed point.
Yeah, go on.
Point above the fixed point, which is particular to the force and the distance in direction of movement.
Okay. Anyone else got another sentence?
The point that the line of action of the board passes through irrespective of position.
We're not quite hitting it. Centre of gravity of an object is the point in which all the gravity force acts. So if you have a mass, the centre of gravity is the point in which the entire gravity force, the weight, acts. Okay, can I go on to B? Okay, B. A trapdoor of length 0.85 of a metre is made from wood of non-uniform thickness. It's attached to a hinge as shown, and it's held into place by applying a force Q of 35.6 at an angle 40. The centre of gravity is 0.39. Determine the mass of the trapdoor. Okay. Alright, okay. So if I draw this here, you have your door, and you have here is the weight, and this distance here is 0.39 of a metre, and then here you have a force P at an angle which we don't know, we'll say theta, and then here you have a force Q which you do know, 35.6, at an angle which you do know. And you also know the total distance. So if we just do 0.85 minus 0.93, 0.85 minus 0.93, is that 0.46? So this distance here you know is 0.46 meters. Okay. They want the mass, which in other words, Joshua, means they want the weight. Oh, I just might need it later. I don't know. Okay, so I think what I'll do is first I'll break this up into a piece this way and a piece this way. So this piece here is 35.6 sine 40, and then this piece here is 35.6 cos 40, and then this piece here is P cos theta, and then this piece here is P sine theta. So you know that P sine theta plus 35.6 sine 40 must equal W. You also know that P cos theta must equal 35.6 cos 40. How did I get the first one? How did I get this one here? How did I get this equation right here? The up force equals the down force. How did I get this one?
The left, right.
Left equals right. There's still one more equation to do. What's that? The turn, yeah, clockwise equals anti-clockwise. I will take this as my turning point. How many forces do I need to consider if I take this as my turning point?
Two.
Did I get that right? Yeah? Two. Which two? the W and 35.6. So we have 0.39 W must equal 0.85 times 35.6 times sine 40. Therefore, W equals 0.85 times 35.6 times sine 40 all over 0.39. What's wrong? Go up? Okay, well maybe someone can type that in on their calculator. What is it? What did you get, Joshua? For the weight? 6.05 newtons. Are you 100% sure? Donna, can I go down now? Yeah, okay. Look, that doesn't matter, I'll type it in. 0.85 times 35.6 times sine 40 degrees, where's my degree, divided by 0.39, 49.87, 49.9. So then the mass equals, because this is equal to mg, I just divide by 9.81. 5.03 kilograms. Part 2 is they want the P and the theta. They want the P and the theta. So if I go back up here, now I need to use these two equations, but I know what the W is now. It has two unknowns in it. No, we don't know the theta. It doesn't say what it is in the question. No? Huh? No, you can't. You need to use these two formulas. So, can you just read these two formulas to me again, just down the bottom here? So, what was my first formula?
P sine theta plus
P sine theta, yeah?
plus Q sine 40.
What?
35.6
Yeah.
and 40 equals W.
Which I know is 49.9. And then the other one is?
P cos theta plus 35.6 cos 40 equals 0. Or minus 0.
This is minus?
Yeah.
Oh, you took it over to the left, yeah. I think I will...
Or it just equals to each other.
Just equal to each other, yeah. Now what I can do is I can clean the first one up because I can take this to the right. So I get P sine theta equals 49.9 minus 35.6 sine 40. Can you type that in as well? So 49.9 minus 35.6 sine 40 degrees, 26.99. And likewise in my second equation here, let me just get rid of that now. What is 35.6 cos 40, please?
What's that?
I'm just getting the 35.6 cos 40, I'm just writing that in. Hang on, say that again, Joshua?
27.3.
Yeah, 27 point, well, I'll write 27. Now, how do you solve these two equations? What do you do? We're looking for P and theta. How do I solve these? That's one way to do it. I think dividing I would prefer. So what I do is I the second equation divided by the first equation. What's sine divided by cos? is tan, and P divided by T is 1. So you get tan theta equals 26.99 over 27.27. So can you tell me what the theta is? You do tan inverse. 44.7 degrees. Yeah? It should be about 45. Now I take this answer and put it back in here to get the P. So P equals 26.99 over sine 44.7. So what's the P, please?
0.603.
Are you sure about that? I don't think so.
Oh, sine.
Making teacher wordy again.
38.37.
That sounds better. 38 point.
37. That's the same thing as whatever you
Coincidental. That's not. Go to the diagram.
Yeah.
Here.
Yeah, and in the question they look like they meet at 90 degrees. They look, but they don't say that they meet at 90 degrees.
Yes, they do have to say that, Joshua. They can't just look like they meet at 90 degrees. I'm sorry to tell you this. Okay, can I go to the C part? I hope I'm jogging memories of semester 1. Memories are being jogged?
Not all.
Not all of them, some of them. Files have been partly recovered? Yeah. Alright, part C. An object of mass 10.85 is at rest and there's a force of 125 newtons applied for 0.2 of a second. What's the velocity? So what you have is mass is 10.85, force is 125, time is 0.2. What formula should I use here? What should I use? Yeah, which one?
F equals 4. times mg.
Very good. You should use the formula impulse equals Ft. Because what's impulse? The change in momentum. And what's momentum change? That's mv minus mu equals Ft. But if it starts at rest, what's u? 0. So then you get mv equals Ft. So then you get v, which is what they want, is Ft over m. So v is 125 times 0.2 all over 10.85 125 times 0.2 divided by 10.85 2.3 meters per second. Can I go to the next part? You have loads of time.
2 minutes.
Loads of time.
Okay.
Part 2. The object then collides with another object and then they move in opposite directions at a speed of 3.67. After the collision, B continues... Object A is then in collision with object B. So I should draw this one. Here's A. It's 10.85. I will go over if I need to. And if you continue to hassle me, it'll just take longer. 10.85, and the other one is 15.62. Moving in an opposite direction. So this one is going to the left with 3.67 meters per second, and this one's going to the right with 2.5 meters per second. After the collision, B continues to move in the same direction with a speed of 1.21. But we don't know what the speed of this one is. I'll call it X. Yeah, what formula do I need to use? Conservation of momentum. So you have M1U1 plus M2U2 must equal M1V1 plus M2. What's wrong? Oh, deliberately, because it's going to the left, so it's a negative velocity. Okay. So you have 10.85 times 2.5 minus 15.62 times 3.67 equals 10.85x minus 1.21 times 15.62. What type of equation is this? Linear.
Shouldn't it be plus 1.7?
No, minus.
But they both of them will move in the same direction.
No, it says after the collision B continues to move in the same direction.
So
I'm assuming the same direction as previously. Although
what about A?
we don't know its direction. So if X is positive, it's going to the right, and if X is negative, it's going to the left.
So how do we know that?
Yeah.
How do we know the sign for the object A?
For which part? The first or the second? We don't know it. So I drew it going to the right. If my answer comes out as negative, it means it's going actually to the left. Yeah.
Okay.
This is easy to solve. It's just a linear equation. So I'll just do solve expression, and you get X is so you see how because X is negative, it means it's going to the left. X is minus 1.04. Don't like this sound now. Okay, can I go on to part 3? What is the change in kinetic energy of A and B? Okay, so the kinetic energy before the collision is a half m v1 squared, which is what? U1 squared, what's that? 2.5. And then plus a half m, which is 15.62 times 3.67 squared. Now, just to save time, can someone type that in on their calculator? And then someone else give me the kinetic energy after the collision. So Daniel, you're giving me the one before, and Joshua, I can trust you to give me the one after. A half 10.85 1.04 squared plus a half 15.62 times 1.21 squared equals.
Why should it be? We need to change.
Yeah, so I'm going to subtract these two. Yeah, this is the first and this is the second. So Daniel, what's the kinetic energy? 139 joules. Okay, and Joshua? 139, sorry. 139 joules. And Joshua, after the collision? What? Are you sure it's that small?
Are you sure?
Did he type it in right? 17.3 joules. Yes? Alright. So what's the change in kinetic energy here? .7 joules. Are you sure it's that small? Hand it up.
velocity is very small.
I can't go back to what you typed in. I'll just have to trust you. This might be a mistake. Okay, the last part now is account for this change in kinetic energy. Meaning, what happened to this kinetic energy? Thank you. The 121.7 joules of kinetic energy was converted into heat and sound energy, but mostly heat. You can see that these questions are not that difficult if you revise and practice. But students don't revise, and then they don't practice, and then they do badly in the exam. And it's such a shame because it's not crazy difficult.
See, I was telling you something different, just need to practice, and you do trust me. Can you trust this smart guy in the front?
Which guy? Alright, let's leave it there.